Hello friends, this is Avin. Welcome to my channel Avin Tricks. This is the 8th video on haloalkanes and haloarenes. This is the continuation of methods of preparation of haloarenes. In this video, we are going to learn how to prepare haloarenes from benzene diazonium chloride salt. This is the structure of benzene diazonium chloride salt. This is benzene and two nitrogen groups are there, therefore it is called as diazonium, and chlorine is present in the molecule, therefore it is called as chloride. So the name of this molecule is benzene diazonium chloride. We can prepare all four types of haloarenes, that is fluorobenzene, chlorobenzene, bromobenzene and iodobenzene more conveniently and satisfactorily from benzene diazonium chloride. The scientist Sandmeyer, he gave the idea and procedure, that is method, how to convert benzene diazonium chloride into chlorobenzene and bromobenzene and cyanobenzene. So in order to honor and respect Sandmeyer, the reaction is named as Sandmeyer's reaction. Another scientist, he gave an idea and method how to convert the benzene diazonium chloride into fluorobenzene. And in order to respect that scientist, the reaction is named as Bal-Schiemann reaction. The scientist Bal-Schiemann, he gave the method to convert benzene diazonium chloride into fluorobenzene. We are going to learn these two very important named the reaction, that is Sandmeyer reaction and Bal-Schiemann reaction with mechanism. Before that, we should learn how this benzene diazonium chloride salt is prepared, because in theory examination they may ask you a question, write a short note on diazotization reaction, or you may also come across a question, how do you prepare benzene diazonium chloride salt? Let us see how to prepare benzene diazonium chloride salt with mechanism, and this reaction is called as diazotization reaction. When primary aryl amines react with nitrous acid at 0 to 5 degrees Celsius, we get benzene diazonium salt. I repeat the statement. When primary aryl amines react with nitrous acid at 0 to 5 degrees Celsius, we get benzene diazonium chloride salt. I will take primary aryl amine, aniline. I take aniline, that is aniline means benzene with NH2 group. It is called as aniline, and this aniline is example of primary aryl amine. Why it is called as primary aryl amine? Because the reason is we know ammonia. Ammonia has the formula NH3. When one hydrogen atom from NH3 is replaced, we get NH2. That is called primary amine. When two hydrogen atoms are replaced from NH3, we get NH group. That is called as secondary amine. When three hydrogen atoms of NH3 are replaced, we get N. That is called tertiary amine. Here, one hydrogen atom is replaced from NH3, so we have a primary aryl amine. The name of this compound is aniline. When this primary aryl amine is reacted with nitrous acid HNO2 at 0 to 5 degree Celsius. When primary aryl amines, for example aniline, when it is reacted with nitrous acid at 0 to 5 degrees Celsius, in NCERT textbook they have given the temperature in Kelvin. We represent 0 degree by 273 Kelvin and 5 degree by 278 Kelvin. So when primary aryl amines reacted with nitrous acid at 0 to 5 degrees Celsius, we get benzene diazonium chloride salt. I will give answer for many questions here. Here, why we are using nitrous acid? Why we are maintaining the temperature at 0 to 5 degrees Celsius? Here, one thing we must remember that nitrous acid means HNO2, nitric acid means HNO3. In the laboratory, HNO3, that is nitric acid, is easily available because it is stable at room temperature and it can be stored. But nitrous acid is unstable and it cannot be stored. Therefore, this nitrous acid must be prepared during this reaction. That means nitrous acid must be prepared while carrying out this reaction. How we can prepare nitrous acid? Nitrous acid can be prepared by the reaction between sodium nitrite, that is NaNO2. When sodium nitrite is reacted with hydrochloric acid HCl, we get, see here, this is HNO2 and NaCl. We get nitrous acid and sodium chloride. That means this nitrous acid is prepared from reaction between sodium nitrite and HCl. So we get HNO2 and NaCl. So during this reaction, NaCl is also formed and water is also formed. This is the method of preparation of benzene diazonium chloride salt. I repeat the statement: when aniline or any primary aryl amine is reacted with nitrous acid at 0 to 5 degrees Celsius, we get benzene diazonium chloride salt and NaCl and water. What is the role of temperature here? 0 to 5 degrees Celsius is very utmost important because this nitrous acid is stable at low temperature 0 to 5 degrees Celsius. Therefore, we must maintain the temperature at 0 to 5 degrees Celsius. And at low temperature, this benzene diazonium chloride is also stable. So, the temperature is 0 to 5 degrees Celsius is required to carry out this reaction. Now we will see the mechanism of this reaction. How this reaction take place. Step by step we study the mechanism. Here we go. Mechanism of diazotization reaction. In first step, sodium nitrite NaNO2 reacts with HCl. We get nitrous acid HNO2. I write HNO2 like this, plus NaCl. This nitrous acid, now I write here nitrous acid like this. This nitrous acid now reacts with the proton of HCl. This is the proton H plus from HCl. This oxygen, it gives its electron to this H plus and it forms H O N double bond O. Now this oxygen has given its lone pair to this hydrogen, therefore oxygen becomes positive. Now oxygen cannot be positive for longer period, so it withdraws the bonded electron and it is eliminated in the form of water. Now we get H2O plus. This nitrogen, it has lost its bonded electron, so it becomes positive. This is the electrophile generated during the first reaction. This is an electrophile. NO plus is an electrophile generated in the first step. In second step, this electrophile, it will attack on the electron rich center of primary aryl amine, that is on the lone pair electrons of the nitrogen. That we are going to see in second step. In second step, this electrophile, it takes the lone pair electron from this aniline. So a bond is formed between nitrogen and this electrophile, that is NH. A bond is formed between nitrogen and oxygen. Now, this nitrogen has given its lone pair, therefore this nitrogen becomes positive. Nitrogen cannot be positive for longer period, so it withdraws the electron from this hydrogen because the hydrogen atoms are easy leaving groups. So, in the next step, we get a lone pair is formed on this nitrogen, and this is double bond O, and this is hydrogen. Now, being oxygen more electronegative, it withdraws the electron from this double bond and it becomes negative. And when this oxygen withdraws the bonded electron, this nitrogen becomes positive. So, nitrogen cannot be positive, so it takes the lone pair electron from adjacent nitrogen atom. So, we have now double bond N, single bond O minus, and here H plus, and this nitrogen has become now positive. Now, a proton, that is H plus, it attacks on this oxygen. So, we get double bond N, O, H, and this is H. Now, the oxygen has given its electron to this proton, therefore oxygen become positive. So, oxygen cannot be positive for longer period, so it withdraws the bonded electron and it is eliminated in the form of OH minus. So, at this stage we get nitrogen, double bond N plus OH minus, Now, the nitrogen cannot be positive for longer period, so it takes the bonded electron here and H plus is eliminated. This H plus will combine with OH minus and it forms water. Now we get nitrogen, triple bond nitrogen. Now Cl minus will form a bond with this intermediate and we get finally N, triple bond N, Cl minus. This is benzene diazonium chloride salt. I repeat the mechanism once again. In the first step, an electrophile NO plus is generated. In second step, that electrophile, it attacks on the electron rich center of this aniline. So we get an intermediate like this. As the nitrogen has given its lone pair to this electrophile, nitrogen becomes positive. So nitrogen cannot be positive for longer period. It withdraws the electron from hydrogen. As the hydrogen is easy leaving group, then we get a double bond between these two nitrogen. And oxygen being more electronegative, it withdraws the bonded electron and oxygen becomes minus. This oxygen, it accepts a proton and it forms OH group and oxygen become positive. Oxygen cannot be positive for longer period, so it withdraws the bonded electron and it is removed in the form of OH minus. Now the nitrogen has become positive, so nitrogen, it takes the bonded electron from the hydrogen. As the hydrogen is easy leaving group, so there will be a triple bond. Then this proton and this OH, they react to form water molecule, and in the final step the Cl minus will form a bond with nitrogen and we get, that is, benzene diazonium chloride. I hope you have understood this mechanism very clearly. Now we are going to learn how this benzene diazonium chloride salt is used to prepare the different types of haloarenes. Here we go. Sandmeyer's reaction: when diazonium group is replaced by chlorine, bromine or cyano groups in presence of copper salt and halogen acid, is known as Sandmeyer's reaction. I repeat the statement. What is Sandmeyer's reaction? When diazonium chloride group is replaced by chlorine, bromine or cyano group in presence of copper salt and halogen acid is known as Sandmeyer's reaction. By the Sandmeyer reaction, we can prepare chlorobenzene, bromobenzene and cyanobenzene more conveniently. When diazonium salt is reacted with cuprous chloride and halogen acid, that is HCl, we get chlorobenzene. And during this reaction, two nitrogen atoms, they are evolved or they are removed in the form of nitrogen gas. If this diazonium chloride salt is reacted with cuprous bromide, CuBr, in presence of halo acid HBr, we get bromobenzene. And nitrogen gas is evolved. And if we react diazonium chloride salt with cuprous cyanide in presence of hydrogen cyanide, we get cyanobenzene and nitrogen gas is evolved. In this way, from Sandmeyer's reaction, we can prepare chlorobenzene, bromobenzene and cyanobenzene from diazonium chloride salt. Now, let us see the mechanism of Sandmeyer's reaction. Mechanism of Sandmeyer's reaction. In first step, this Cl- will form a bond with copper and it is removed in the form of Cl, Cu, Cl, and this will become an intermediate species nitrogen, triple bond, nitrogen with a lone pair. In second step, this single bond between copper and chlorine, it undergoes homolytic, that is symmetrical breaking, and it produces two free radicals. At the same time, this benzene and nitrogen bond also undergoes symmetrical breaking and it produces two free radicals. Benzene free radical, and here we have another free radical like this. This copper, it gives one electron to this and it is now converted into nitrogen gas. And this chlorine free radical, it shares its electron to this benzene free radical and we get chlorobenzene. We get chlorobenzene. In this way, from Sandmeyer's reaction, we can conveniently prepare chlorobenzene. This is the mechanism of Sandmeyer's reaction. In the same way, we can also explain the mechanism of formation of bromobenzene and cyanobenzene. Now we will see Bal-Schiemann reaction. The scientist Bal-Schiemann, he gave an idea how to convert benzene diazonium chloride into fluorobenzene. When benzene diazonium chloride salt, when it is heated with hydrogen fluoroborate, that is HbF4, in presence of sodium fluoroborate, NaBF4, after heating we get fluorobenzene and nitrogen gas and BF3. This is known as Bal-Schiemann reaction. I repeat the statement. When benzene diazonium chloride salt is heated with hydrogen fluoroborate in presence of sodium fluoroborate, we get fluorobenzene, nitrogen gas and BF3. Now let us see the mechanism of this reaction, Bal-Schiemann reaction. Mechanism. In first step, this benzene diazonium chloride salt, it reacts with hydrogen fluoroborate, that is BF4. This chlorine, it forms a bond with hydrogen and it is eliminated in the form of HCl. And BF4, it will occupy the position of this chlorine. So we get an intermediate like this. N triple bond N BF4. At high temperature, this molecule undergoes decomposition and this group is removed in the form of nitrogen gas and BF4 plus benzene cation. I can write this BF4 in this manner, that is BF3 F minus. This F minus, it will attack on this benzene cation and we get fluorobenzene. Plus BF3. In this way, we can prepare fluorobenzene by heating benzene diazonium chloride salt with hydrogen fluoroborate in presence of sodium fluoroborate. This reaction is named as Bal-Schiemann reaction. In order to honor the scientist, the reaction is named by their name, that is Bal-Schiemann reaction. We have seen the preparation of chlorobenzene, bromobenzene and fluorobenzene. Now the question comes, how to prepare iodobenzene? That iodobenzene can be very easily and very conveniently prepared by simply mixing benzene diazonium chloride with potassium iodide, we get iodobenzene. No need to use here cuprous salts. Simple mixing and shaking of potassium iodide with benzene diazonium chloride, it produces the iodobenzene and nitrogen gas is evolved during the reaction. Now we will see the last method of preparation of haloarenes, that is Gattermann reaction. Gattermann reaction is also known as advanced version of Sandmeyer's reaction. Why it is called as advanced version of Sandmeyer reaction? We know that in Sandmeyer reaction we had used the benzene diazonium chloride salt and cuprous salts. Here instead of cuprous salt we have to use simply copper powder and hydrogen halide, where X, that is X is chlorine or bromine, where X is Cl or Br. After heating we get haloarene. If we use HCl we are going to get here chlorobenzene. If we use HBr we get the bromobenzene. This is simple advanced version of Sandmeyer's reaction and this is discovered by the scientist Gattermann. In order to respect him, the reaction is named as Gattermann reaction. Once again I repeat the statement: when benzene diazonium chloride salt is heated with copper powder in presence of HCl or HBr, we get respective haloarenes. If we use HCl we get chlorobenzene, if we use HBr we get bromobenzene. In this video we have seen the methods of preparation of haloarenes from benzene diazonium chloride salt, and we have studied with Machanism Sandmeyer reaction as well as Bal-Schiemann reaction and Gattermann reaction. I hope you have enjoyed this video. In next video we are going to learn physical and chemical properties of haloarenes. Like, share the video and please subscribe to my channel. Please tell to your friends to subscribe my channel and keep watching my videos. This is Avin. I'm thankful to you as well as I'm thankful to YouTube and millions of YouTube viewers.